Here are two objectives from Chapter 8, Objective 5 and Objective 19. Objective 5 asks to write out full and abbreviated electron configurations of both elements and ions. And this is my kind of sort of general diagram of a periodic table showing the different letters we're going to use depending on where we are in the periodic table. The ones on the left are S, transition elements are D, the ones on the right are P, and the ones below are F. And remember that D is always 1 less than S and P. F is always 2 less. And when you're talking about ions, you're always going to take from S and P first. And I'll show you in the examples, and you'll get the hang of it. It's simple enough once you try it a few times. So anyways, I'm just going to show you one. The coefficients tell you what row you're in, and then the exponents tell you the maximum electrons that it can hold. So I'm just going to show you bromine. It's in row 4. So what we do is we start with 1s2, 2s2, 2p6. You have to do this with a periodic table, just so that you can count. And then remember, once we get to D, we go 1 less, so it's just going to be 3D, and it can hold 10 electrons. And we go back to 4. And because bromine only has 35 electrons, not 36, it's not going to go all the way. It only holds 5 electrons. Once you look back, it's going to look like these are the rows. These you could look at as like columns, or you could add them all up. The exponents, it would be the atomic number. Anyways, that's bromine. The full form, then the abbreviated form, also called the kernel method, is where you start with a noble gas and then work your way to the element. So when you go backwards, the closest noble gas is argon. So we're going to put that in a little parentheses here. And then you say, how much do I need to get to the bromine? So you add kind of beyond argon. What's going to get me there? So that'll be 4s2, 3d10, 4p6. So it's just repeating this last part, putting it up here. So you still get the same element, it's just shorter. And then I'm going to show you the chlorine. The chlorine ion, which is -1. And it's very similar, it's just you have to count the electrons a little differently. So I'm going to start again with 1. Oh, that's not coming up.
Oh, switch markers.
Oh, there we go. First row, second row. And then we don't normally chlorine will only have 3p5, but because it's an ion, it has an extra electron. It's a -1 charge, so it's actually going to be 3p6. It's like the noble gas. So that's one example. Then this is a tricky one. Indium ion. Remember, you always take from S and P first. So I wrote this down. The original, I'm going to write this in abbreviated form. The original ion normal form would be krypton, which is its closest noble gas, plus 5s2, 4d10, 3p6. But because it's +2, we're going to have to take 2 electrons away. But watch where I'm going to take it away. I took it away from our P and the S. So the 4d10 just stays the same. It stays 10. But I took one electron away from the 5s row and one electron away from P. So that's how we write the electron configurations. And then objective 19 says draw geometries using a VSEPR, valence shell electron pair repulsion. And there's 5 different types, so I'll just draw them out for you. Linear, I think, is the easiest, so sorry, I kind of forgot it needed space. And that's pretty simple. I'm going to let you know right now that a straight line means it's just something in a plane. A triangle means it's coming out of the plane, it's coming at you. And then, like, dashed lines means it's going backwards behind the plane. So these are all on the same plane. It's just C and 2 oxygens. And then a trigonal planar compound, it's going to have 3 bonds. It's going to still just be solid lines, but just 3 of them. So we still have our B, and we still have 3 fluorine coming out around it. And that is trigonal planar. I'm going to skip over the trigonal pyramidal. It also has 3 bonds, but it's going to have 1 lone pair as well, which is tricky, and I'll show you. It has 1 pair that's just not connected with, not bonded with. So, and then here's where our symbols come in. We're still going to use a solid line, but then a little triangle to show it's coming out in front. And then dashed lines to show that it's coming behind the plane. And that's trigonal pyramidal. And then let's do tetrahedral. So CH4 is the compound. And this time it's going to have all 4 bonds. Alright. So one's going to be a straight line. One is going to be a triangle. One is going to come out behind. And then one is going to, oh, I'll delete that. One is also still going to be on the